All right, welcome back to Statistical Analysis and Psychology. This is week 14, class number 1, and this is where we're going to wrap up our look at chapter 9, the t-test for independent means, and actually wrap up our entire look at t-tests in general. So thank you for joining me on week 14, class number 1. This is day 5 or class 5 of the face-to-face shutdown. Quarantine beard is coming in nicely, so let's launch into chapter 9 and finish up our look at the t-tests in general. But before we get to that, just a brief announcement about exam number 3. So exam number 3 is going to be our first face-to-face shutdown exam. So it's going to be a little bit different than our previous exams, naturally, because we're not going to be able to do it during class time. So this is the way that it's going to work. I'm going to post an announcement to this in Canvas, but just to give you a heads up, this is the details on exam number 3. So in terms of the date and time, what I'm going to do is this is going to be a take-home exam, and you are going to have a 24-hour period in which to complete this exam. So it's going to be available in Canvas beginning April 12th, just after midnight. All right, so 12:01 a.m., this is going to go live on Canvas, and then it's going to be due in Canvas by midnight of that day. So you have all of April 20th to complete exam number 3. It's going to be exactly like the previous exams. But I will just post this on Canvas, download it, complete it sometime during April 20th. I'm opening this up for 24 hours because I know people's schedules have gotten thrown out of whack. So just to accommodate anybody who might not be able to make it to class during that time, we're going to do it in this 24-hour period. And then it's going to cover the chapters that we covered, chapters 6, 8, and 9. And specifically, it's going to cover hypothesis testing. So most of the exam is going to be hypothesis testing for this time, for this exam number 3. So speaking of what it's going to be like, once again, it's going to be a computational exam. The format of the exam is not going to change. It's going to be available in Canvas. It's going to be 7 questions. And it is a take-home exam, but I just wanted to reiterate that it is open book, open everything except collaboration with other people. And what you are going to want to do, again, it's a little bit different this time, but the more that you can prepare your materials in advance, the easier it's going to be to complete this in the given time. Now, I know that's a little bit different when you have 24 hours, but just bear in mind that it's best not to learn the material day of, but to go in there knowing that material beforehand. So to kind of help you know what's coming on that day for exam number 3, I am going to post exam number 3 template questions into Excel and into Canvas. And this will just give you a general idea of the format of the questions. They're going to be hypothesis testing questions where you are going to have to decide which t-test you want to do, set it up correctly, enter it into SPSS, and then interpret the output correctly. So this is going to be a completely hypothesis testing exam, and you will need to identify the hypothesis test, format the data, enter it into SPSS, run the hypothesis test, and then correctly interpret the output. Basically what we've been going over these past few weeks. Now, to help you get prepared for this, we are going to have our regularly scheduled review sessions. So the review session is going to happen. Next class is going to be week 14, class number 2. That's April 14th. And it is going to happen during the regularly scheduled class times. It's going to happen at 10 a.m. And it is going to be an open review session. And we're going to do this live via Zoom meetings. So on that day, I'm going to make a Canvas announcement, where I will post the meeting link. And then I will be here in the Zoom meeting rooms, waiting for anybody that might want to come on by and just go over any last minute things before the exam. So that's going to be just like our typical review session. It's going to be completely student driven. I have nothing that I in particular feel that I would need to go over. So it's going to be completely based on your needs. And as such, it's completely optional. So feel free to join me for the Zoom meeting, or if you feel your time is better spent preparing in another way, absolutely do that as well. But I will post that Zoom link to Canvas announcements before that meeting, and then I will be there waiting for anybody that might need help, any sort of final questions about hypothesis testing and specifically the t-test. All right, so what we're going to do today is we're going to finish up our look at t-tests by basically going over how to identify which t-test you actually need to do, and then just give you a demonstration of the importance of choosing the correct t-test. So up until this point, we've been going over the three types of t-tests. And for the Harlow monkey study on infant attachment, we decided that we were going to do a one-sample t-test. But this was not really a decision that came difficult because we were in the chapter about one-sample t-tests, right? And we were literally told in class, do a one-sample t-test. But in the real world, Harlow had to take a look at the characteristics of his experiment and decide that the one-sample t-test was the correct hypothesis test to do in that situation. And that's what we're going to be taking a look at today. So when we did the study, when we analyzed the study on adult timeout to find out that adult timeout is also effective, that placing adults in timeout is effective, we did a dependent means t-test. And we decided to do that because that was the order of the day. That's what we were covering on that day. Basically, it was decided for us to do a dependent means t-test. Today, we're going to take a look at how to look at the characteristics of that experiment and then decide on our own to do a dependent means t-test. And then lastly, when we did the Loftus and Palmer study, when we took a look at the Loftus and Palmer study on eyewitness memory and how questions can change those memories, we did an independent means t-test. And once again, we did this because we were in the independent means t-test chapter. So it was as if the decision was already made for us. But in order to get us to the point where our skills are ready for the real world, we need to be able to decide between those three t-tests. Because in the real world, you're going to have to choose which one of those is the correct t-test for any particular situation. So we're going to begin today by taking a look at a method where you can select which one is correct. And then we're going to take a look at the implications, the reasons why it's so important to choose that correct t-test. So that's what we're going to be concentrating on today. I'm going to give you a general guide for choosing hypothesis tests in general. So this is going to be a little bit broader than what we need right now, but it will contain that portion on choosing the correct t-test. And then we're going to go through an in-class demo on the importance of choosing the correct t-test. And we'll end it with a mention of your homework assignment, a mention of the MyStatLab study plan, and just a few key reminders going into this exam, getting ready for exam number 3. All right, so the general guide for choosing hypothesis tests. This is one way of doing it. I'm going to give you a kind of a flow chart, the way that I think about it. You can think about it in different ways, but I do want to present you with at least one way of navigating this decision. So typically what I do is I start by asking myself, how many independent variables are there in this experiment? So an independent variable, that's the cause. That's what you're manipulating. That's what you're trying to test. You're trying to test if this treatment actually causes a difference. So that cause that you're testing, that's your independent variable. And if you have 2 or more, then that is actually outside the scope of this course. So this is Introduction to Statistical Analysis. You'll find out how to test experiments with 2 or more variables in a later course, probably when you go to grad school. Now, just be aware of that because many psychology experiments, maybe the ones that you want to do for your advanced lab, will have 2 or more independent variables. So how does depression interact with alcohol consumption, to cause suicide rates? That's 2 independent variables, depression and alcohol consumption. Very interesting studies. Just know that you have not been taught those skills. Those are outside the scope of the course. So if you do decide to do one of those experiments for your advanced lab, feel free to knock on my door when it comes time to analyze the data, and I'll be more than happy to kind of run you through it and say, all right, this is the hypothesis test that you need to do for that situation, because you will not learn that in this class, right? It's just, I wish we had another 2 weeks and we could have made it, but it's just to spend the time that we need on the test that we're looking at, we couldn't quite make it to 2 or more independent variables. But good to know that so that you're not wondering how to do that. You didn't miss anything. We're not covering that in this course. What we have covered in this course are the situations where you have 1 variable. You have 1 cause. You're testing 1 thing. So type of mother, that was 1 variable, right? Length of time out, that was one variable. The way that you phrased a particular question, that was one variable, right? So we were only looking at one cause. So once you identify that you only have one variable, the next thing you have to ask yourself is how many levels, how many different values does that variable have in this particular experiment? And that only has two sort of categories that you need to worry about. So the number of levels, if it's 3 or more, so if there's 3 different values that a variable can take, well, that is going to be analyzed with what's known as an ANOVA. That's coming soon. That's going to be the final week in this course. We're going to take a look at that very powerful hypothesis testing statistical test known as the ANOVA. So far in this class, we've only been dealing with variables that have 2 levels, right? So only 2 values. And when you have one variable with 2 values, you do a t-test. So we were only ever testing experiments or looking at experiments where a single variable had 2 values. So it was type of mother, and it was terry cloth or wire mesh. It was timeout length, and it was 5 seconds or 10 seconds. It was type of question, and it was hit or smashed, right? So there was only ever 2 values, only ever 2 levels for each of these variables. So that's where we get to where we're right now, right? So in this exam number 3, you're going to be doing a t-test, right? That's already been decided. This is an exam on t-tests, right? This is the portion of the course where we have focused on t-tests. Now it comes down to the point of which t-test. So for this, you want to ask yourself certain questions. I like to begin with the question of how many times is each individual subject measured in this test? How many times does each individual subject produce a raw score, right? How many raw scores does each individual subject have? And there's only going to be two answers to that, 2 possible answers. So how many times is each subject measured? They could be measured twice, right? They could be measured before treatment, and then the same subjects are measured after treatment. They could be measured on drug A, and then the same subjects are measured on drug B. They could be measured under a 5-second timeout condition, and then later be measured on a 10-second timeout condition. If they are measured twice in the same experiment, then you do a dependent means t-test. You've made your decision. You're ready to go to SPSS. On the other hand, if each subject is only measured once, then we have to do a little bit more digging. We have to do a little bit more analysis, and we have to ask ourselves, how many samples are there? How many subjects are there that have been treated differently? How many groups of subjects have been treated differently in this experiment? And again, there's only 2 possible answers for this. How many samples are there? There might only be 1. There might be just 1 sample, and everybody is treated the same in this particular experiment. If that's the case, then you're dealing with a single sample t-test. So if you recall Harlow's monkey trial, all of the monkeys were given the same exposure to the terry cloth mother and the wire mesh mother. All of the monkeys were treated the same. They weren't placed in 2 separate groups. They were just one group, one sample of monkeys. That's what made that a single sample t-test. So if you reach this conclusion, you're done. Time to go to SPSS. On the other hand, if there are 2 samples, 2 groups of subjects that have been treated differently, so one group gets drug A, and then the separate group gets drug B, or one group is asked how fast were the cars going when they hit each other, and then another group is asked how fast were the cars going when they smashed into each other. You have 2 separate samples. Excuse me. You have 2 separate samples. That is an independent means t-test. So that is your general guide for how to get to a particular statistical hypothesis test. For our purposes, we're going to start where it says t-test. So for exam number 3, you know you're going to be doing a t-test, right? I'll tell you right now, every single question is going to be a t-test. So start there and ask yourself, how many times is each subject measured? Is it once or twice? If they're measured twice, dependent means t-test, you're ready to go with the hypothesis test. If, on the other hand, they're only measured once, ask yourself how many samples there are. If it's only 1 sample, you're dealing with a single sample t-test. If there's 2 samples, you're dealing with an independent means t-test. go through the selection process and identify, based on the description in the experiment, which of these t-tests you're actually dealing with. All right, so now that we have that kind of flow chart, let's apply it and take a look at the importance of choosing the correct test. So why are we so concerned that we use the correct t-test? Well, as we're going to see, there are wildly different results that can be attained if you use different t-tests. And what that means is that if we want to get to the truth, if we want to find out what is really happening in psychology, and we don't want to make mistakes with people's lives hanging in the balance, right? We've been given a huge responsibility. We need to make sure that we are getting as close to the truth as possible. We need to make sure we're analyzing this data with the right test, because choosing the wrong test can completely reverse your conclusion. It can take a rejection of the null hypothesis and turn it into a rejection of the research hypothesis, as we're going to see in this example. All right, so let's take a look at this description here, and we're going to make a decision in terms of which test we're going to use for this particular experiment. So I'll read it out loud for you. It goes, people often forget names, but they believe they never forget a face. Is memory for faces better than for names? A researcher tests 34 subjects. Half of the subjects are asked to memorize a series of 30 faces. Later, they are tested with a recognition task for the faces. The other half of the subjects are asked to memorize a series of 30 names. Later, they are tested with a recognition task for the names. So we have 34 subjects. All of them are tested once, right? They are all tested one time for recognition for either names or faces. However, they are two samples. So we have them being measured once, so we know it's not a dependent means t-test, and we have two separate samples. We have a sample of subjects that are shown faces. We have a sample of subjects that are shown names. Two samples dealt with differently, according to our flow chart, that's an independent means t-test. So by reading the description and asking questions and finding that information that we need, we decide that in this case, we are dealing with an independent means t-test. What that means is that we have 34 subjects, and they got split into two groups. So subject number one in the face memory condition that got a score of 69.1% accuracy, that's not the same person as subject number one in the name memory condition, who also scored 69.1. So the 17 subjects in the face memory condition are completely different people than the 17 subjects in the name memory condition. And that makes sense because we have 34 subjects total. We took the 34, we split them into two groups of 17. So there are the raw scores. We see the accuracy scores for the face memory subjects. We see the accuracy scores for the name memory subjects. Now we've decided to use an independent t-test to determine whether those accuracies are different. Specifically, we want to know, are the accuracies higher for the face condition? So do the data indicate a significant difference? We're going to use a one-tailed test with an alpha of 0.05, and we want to know, is memory for faces better than, higher than, greater than memory for names? So we're going to do this one-tailed test, and we're going to have an alpha of 0.05. All right, let's start up with this. So we're going to go through this a little bit quicker than we normally go through hypothesis testing, just because we've seen these before. And the purpose of today is to really identify the importance of choosing the right hypothesis test. So if you need to, pause the video if it's going a little bit too fast for you to follow along. Make sure that you are going through and everything is making sense, because this is the last new piece of information that we have before exam number 3. All right, so let's start off with step number 1. Restate the question as a research hypothesis and a null hypothesis about the population. We want to know, do people have better memory for faces than for names? So the research hypothesis is that memory is better for faces, and we write this out as the mean accuracy for faces is greater than the mean accuracy for names. So the mean accuracy in the population for face memory is greater than the mean accuracy in the population for name memory. Now, that is a research hypothesis, and it's one tail. So notice it's only greater than. The mean accuracy for faces is greater than the mean accuracy for names. The null hypothesis has to be the complete opposite of the research hypothesis. So memory is better for faces is the research hypothesis. The null hypothesis is then memory is not better for faces. Research hypothesis is that the mean for faces is greater than the mean for names. Null hypothesis is that the mean for faces is less than or equal to the mean for names. And that's because the research and the null hypotheses have to cover all three possibilities. That memory is better for faces, memory is equal to for faces and names, or memory is worse for faces. And all three of those is covered in our null and research hypothesis taken together. So that's the null and the research hypothesis. Step number 1 completed. Step number 2, determine the characteristics of the comparison distribution. Thank goodness SPSS will do this. So we just have to know where to read that information. Step number 3, set a cutoff probability. This comes from your question. Your cutoff probability is equal to alpha. So we are no longer using lines in the sand with cutoff statistics. We're no longer using cutoff t-scores. What we're doing is we're using cutoff probabilities. Your cutoff probability is your alpha level. And in this case, alpha level is 0.05. Next thing we need to do, determine your sample score on the comparison distribution. We're going to switch this to determining our sample's probability on the comparison distribution so we can compare it to our probability line in the sand from step number 3. This is your p-value, and SPSS will calculate this for you as well. So we're ready to go on steps 2, 3, and 4. So we're going to now turn to SPSS. So if you haven't already, go into IU Anywhere, open up the SPSS program. And also, if you haven't already, log into Canvas and open up the Excel sheet for week 14, class number 1. So what you're looking for is, let me just get this. What you're looking for is this Excel sheet right there. So as you can see, it's got the raw data that we need. It's got memory for names, memory for faces, and that is in Canvas. So let's start up right now with doing this. So we've decided to do an independent means t-test. We have made that decision based on the characteristics given to us in the description of the experiment. So based on the fact that we have 2 separate groups, each of which is measured 1 time, that's an independent means t-test. So let's begin with our SPSS, and we will start this up. So the first thing we need to do is we need to start moving data in here. So we're going to copy all of our face accuracy scores, and we're going to copy those, and we are going to paste them into SPSS right there. And then what we're going to do is we are going to label this as memory. Let's call it memory. So these are the memory scores. And then what we're going to have to do here is we're going to need a second column where we indicate what it is that they are trying to remember. We indicate what group they belong to. So that's the memory score. This one is the group variable. So we have the memory variable, we have the group variable, and right now we have the scores for the face group. Next thing we need to do is we need to take the memories for the name group. And we remember the principle that every single subject gets their own row. So because of that, we know that these scores go right there, starting in row 18. So row 1 through 17, those are for the subjects in the face condition. We need new rows for the subjects in the name condition. That's row 18 and on. We need to label these so that we know we can tell SPSS what group these guys belong to. So we do that, and we now have a properly formatted data editor input for SPSS. So now that we have the properly formatted data, and again, if you need to pause at this point to get your data in, feel free to do so. If not, come with me. So once we have that in there, we go to Analyze, we go to Compare Means, we go to the Independent Samples t-test, and we put in the test variable as memory. And remember that you cannot put in the group variable there. SPSS will stop you. So if you get that that warning right there. If you get that error message, just know that something might have gone wrong or you're choosing the wrong variable. So the test variables are where our raw scores are. The grouping variable, very intuitively, that's group. And then you'll notice that it says group and it's got 2 question marks. What are your names of your group? So we're going to click on define groups. And group number 1, that is called face. And group number 2, that is called name. And we hit continue. And we hit OK. And lo and behold, we have our t-test run and done, and it is ready to go. So at this point, we have done the data editing and the formatting of SPSS. So now what we need to do is we need to take a look at that data and we need to interpret it. We need to find out the information that we require for steps 2 and 4. And we also need to then decide with step 5, what do we do? So decide whether to reject or accept a null hypothesis. Remember that if the p-value, if the probability of your sample is less than alpha, your probability lines in the sand, you're going to accept the research hypothesis and you're going to reject the null hypothesis. If, on the other hand, the p-value is greater than your alpha level, you're going to accept the null hypothesis and you're going to reject the research hypothesis. So let's take a look at our output. We'll zoom in there a little bit. As always, check your top table there labeled group statistics. This is going to save your life because you are a human and you will make mistakes. And this is where you catch your mistakes. So you always want to check that top table with group statistics. We got 1 row for face. We got 1 row for name. And we want to make sure that our data has been entered correctly. So we check the column labeled N. This tells us how many scores SPSS has for each group. And SPSS is telling us I have 17, or I found 17 scores in the face sample. I found 17 scores in the name sample. And we double check that and say to ourselves, you know what? That's how many people are supposed to be in those samples. Makes me feel confident I did this correctly. You can check the mean for each sample. And SPSS is telling us the mean for the face scores is 84.5. The mean for the name scores is 81.9. And we check in Excel and we can calculate the means for that and just double check and make sure that nothing has gone wrong. There was no copying and pasting errors. There was no labeling errors. Again, giving us confidence that we've done this correctly. Once we have that confidence, we can go to the independent samples test table. That's that second table down there. Remember that we are dealing with the equal variances assumed row. Do not worry about the equal variances not assumed. That is going to be your grad school statistics course. But for right now, we're going to deal with step number 2. We need information on our comparison distribution. We need the degrees of freedom. That's where we find the degrees of freedom. We got 32 degrees of freedom. We need the estimated standard error, the standard deviation of our comparison distribution. That's where we find it right there. So SPSS helps us to do step number 2, characteristics of the comparison distribution. And again, make sure that you're making a note of where to find that information for each of the 3 t-tests. All right, so we have step 2. Step 3, we've already done. That's our cutoff probability. That's our alpha level. That's 0.05. So now we're moving on to step 4. Step 4 is where we need to find the t-statistic for our sample and our sample's probability. And just so you have a peek behind the curtains, that mean difference right there, that's the difference between the 2 samples. That's the difference in accuracy between the face and the name conditions. And that mean difference divided by the estimated standard error gives you your t-statistic. So there's your t-statistic right there for this sample difference. Your t-statistic is 0.874. And the probability of getting a t-statistic that large, if there wasn't any difference between names and faces and their accuracy, that's what our p-value is. That's what our probability is. And importantly for us, we can find that probability right there. So SPSS has calculated the two-tailed significance of this. And that's going to be very important because we are doing a one-tailed test here. So we can read off the two-tailed probability. But remember, that's a probability going high or low. That's a probability for 2 tails. We don't care about the low part. So we have to take that number, 0.388, and we got to divide it by 2 to get rid of one of the tails. That's a probability for 2 tails. We only want 1. So we're going to divide that by 2, and the p-value that we're going to use is 0.194. It's 0.388 divided by 2, that's 0.194. So that's the number that we're going to use to help make our decision. So if our p-value is less than alpha, we got 0.194, our alpha level is 0.05, our p-value is not less than alpha. So we're not going to do this. We're not going to do what's on this slide. We're not going to accept the research hypothesis. We're going to do what's on this slide. Our p-value is greater than alpha. We got 0.194, alpha is 0.05. So we're going to accept the null hypothesis, and we're going to reject the research hypothesis. So once again, that comes from the fact that our two-tailed significance is 0.388, which means that our one-tailed significance is that divided by 2. 0.194 is greater than 0.05, so we end up accepting the null hypothesis, and our conclusion is that people are not better at remembering faces than remembering names. So according to this statistical analysis, people are not better at remembering faces than remembering names. It's a myth. It's not actually the case. And all of this came out with the data that we used, and we used an independent means t-test to analyze that data. All right, so that was that data with an independent means t-test. What we're going to do right now is we're going to take a look at a second analysis. And importantly, and this is critical to understand, we're going to do a dependent means t-test, but we're going to use the exact same data. All right, the exact same data set that we just used, but this time we're going to do a dependent means t-test. So let's look at the data experimental description for that. So let's say that this was the experiment. People often forget names, but believe that they never forget a face. Is memory better for faces than for names? A researcher tests 17 subjects. The subjects are asked to memorize a series of 30 faces. Later, they are tested with a recognition task for the faces. The same subjects are also asked to memorize a series of 30 names. Later, they are tested with a recognition task for the names. So notice we have 17 subjects measured once for the face condition, and then those same subjects are measured again. They're measured twice for the name condition. One set of subjects measured twice, that's a dependent means t-test. So we make our decision, we're going to use a dependent means t-test. Very importantly for this demonstration, the data is exactly the same. We're going to use the exact same raw data, the exact same numbers, the exact same accuracy scores, but this time we're going to analyze it with a dependent means t-test. So we still want to know the same question. Does the data indicate a significant difference? We're still going to use a one-tailed test with an alpha of 0.05. Nothing has changed, except now we're doing a dependent means t-test instead of an independent means t-test. So let's see what happens. So we're still doing the same 5-step procedure. Step number 1 has not changed. We still want to know, do people have better memory for faces than for names? Our research hypothesis is still that memory is better for faces. That is, the mean accuracy for faces is greater than the mean accuracy for names. Our null hypothesis is still the complete opposite. Memory is not better for faces. The mean accuracy for faces is less than or equal to the mean accuracy for names. Step 2, determine the characteristics of the comparison distribution. This is going to change, but still SPSS is going to do this for us. Thank you, SPSS. Step number 3, set a cutoff probability. This doesn't change. So we're still using a cutoff probability of alpha. That's still 0.05 for this question. That hasn't changed since our previous analysis. Determine your sample score on the comparison distribution and determine your sample's probability on the comparison distribution. That is the p-value. SPSS is going to do this, and as we're going to see, this is going to radically change. All right, so get ready for that because that's where the big difference is going to occur. So we're ready to go on steps 2 and 4, 2 through 4 for this hypothesis test. So once again, we're going back to the data. Once again, we're going back to SPSS. So let's set that up right now. So what we're going to do is we are going to close this out, this output here. So we're not going to save that. And then we're going to clear this data. So I'm going to highlight the entire column and then just hit delete so that we have a fresh data editor to start with. All right, so this time we're going to go to our raw data here. And once again, we're going to copy and paste this. And we're going to start by copying and pasting it into the first column here. And that was the face data, right? The face memory scores right there. So we are going to label this variable 3, and we are going to label that as face. All right, so we labeled it as face. Now we need to take our name scores here, and we need to copy and paste those into SPSS. Now, importantly, we need to realize that these are the same subjects. Subject number 1 in the face memory condition is subject number 1 in the name memory condition. Subject number 6 is the same in both of those samples. These people have been measured twice. So we look to the rule in SPSS that each subject gets one and only one row. So that requires that we paste the name data into column number 2, row number 1, and let's just call that name. All right. So we have the face data, we have the name data, we're good to go, we're ready. We go to analyze, we go to compare means. We remember that the dependent means t-test is labeled paired samples t-test in SPSS. So we choose that option. And then here we're going to put face in as variable number 1, and we're going to put name in as variable number 2. And once we've done that, we can hit OK. And we have our output ready to go. So in this case, it was pretty quick to do, but let's analyze our output. So we're done with SPSS. Now all that remains is to analyze the output that we have. So let's get going on that. And again, we're doing this so we can figure out what to do in step 5, because we need to decide whether to reject the null hypothesis. So again, if the p-value, the probability of our sample, is less than alpha, our lines in the sand, then we're going to accept the research hypothesis and we're going to reject the null hypothesis. If, on the other hand, the probability of our sample, our p-value, is greater than alpha, our lines in the sand, we're going to accept the null hypothesis and we're going to reject the research hypothesis. So let's zoom in on this and see what's going on. So once again, always go to that top table and make sure that all your data has been entered correctly. Just double check it. So we go to that top table, paired sample statistics, and lo and behold, SPSS gives us the same means that we have calculated in Excel. So we know that we've entered in it gives us confidence that we've entered in the data correctly. And in column number 3 there, SPSS is telling us there are 17 scores in the face condition. There are 17 scores in the name condition. And we double check our data and we say, yeah, we have 17 subjects. Good for you, SPSS. You got the whole thing. So we double check with the top table there. We completely ignore table number 2. Don't worry about table number 2, right? Grad school is table number 2. What we're going to do now, though, is we're going to go to table number 3, paired samples t-test. And this is where we're going to find our step 2 comparison distribution characteristics. So we have to find the standard deviation for our comparison distribution, our estimated standard error, and that is right there. And then we also need the degrees of freedom for our comparison distribution, and we get that right there in this table. So notice already we've gone completely different from the independent means t-test. These are very different values than what we had for the comparison distribution for the independent means t-test, and that's going to be a big effect on step 4. So this is step 2. Make sure that you know where to find that information. Step 3, our comparison probability. That's the alpha level. We've already decided that's 0.05. So what we need to do now is we need to find step 4, our our sample t-statistic and our sample's probability. So we take a look at our paired samples t-test. We note that it's face minus name. All right, and this is in the correct order for the question that we're doing, because we want to know are faces better than names in terms of accuracy. And with this order, if faces are better, we're going to get a positive difference here. And that's just going to help our minds make sense of this a little bit easier. So it's not essential, but make sure, just kind of double check that. Make sure that it's not requiring you to do mental gymnastics. So, in this case, it's in the direction that makes intuitive sense for us. It makes it easier for us to understand. If it wasn't, we can go back and we can just flip those variables. I've showed you how to do that before, but it's in the right direction this time, so we can go forward. That mean difference divided by your estimated standard error is going to give you your t-statistic. So there's the t-statistic for your sample. There's your sample's t-statistic. So 4.857, that's the sample t-statistic. And given that t-score, we can figure out the probability of getting a sample that weird if the null hypothesis is correct. And that is our significance here. So it's a significance two-tailed. So we got to do a little bit of work on it, but that's what that p-value is from. It's that significance two-tailed. So it's 0.000. There's actually a number there somewhere, but SPSS can't display it. So for all intents and purposes, we can think of this as 0.000. It's two-tailed though, so we got to divide that by 2. 0.000 divided by 2 is still 0.000. So we have a p-value of 0.00. So we go to our decision slides, and it says if the p-value, the probability of our sample, is less than alpha, our line in the sand, 0.000 is less than 0.05. So we're going to accept the research hypothesis and we're going to reject the null hypothesis. If it was the other way around, we would accept the null hypothesis and reject the research hypothesis. As it is, though, our p-value is not greater than our alpha level. So once again, p-value, that significance two-tailed, nowhere to find it. This one is two-tailed. We're doing a one-tailed test. So as you see, we have to divide that by 2 because it's the probability for two tails, and we got to get rid of one of those tails because we are only interested in that one tail. So 0.000 is less than 0.05. So in that case, we reject the null hypothesis, and we conclude that people are better at remembering faces than remembering names. So notice, completely opposite conclusion. For dependent means t-test, people are better at remembering faces. For an independent means t-test, people are not better at remembering faces, right? So completely different conclusion with the exact same data, illustrating the importance, the vital importance of making sure that we're choosing the correct t-test. All right, so that's all that I wanted to cover for today. Just a couple of reminders before we sign off for today's class. So the MyStatLab study plan for chapters 6, 8, and 9, this is due April 19th by midnight. All right, so this is due right before the exam Excel sheet goes live. All right, so this is kind of typical to what we've been doing before to help you prep for the exam. That's when your pre-test study points are going to be due April 19th by midnight. In terms of your homework assignment, number 12 for chapter 9, you are now fully ready to go. That is due April 15th by 11:59. And as well, your chapter 9 post-test, which you are now prepared for, also due April 15th at 11:59. So that is it for today's class. Join me next time in the review session if you would like to drop on by. Again, I'll be putting that Zoom link into Canvas announcement. So feel free to come on by if you need any help preparing. Thank you so much for joining me for today's class. Keep yourself safe, and I will see you next time.